Hello. This video is to explain the material in the introduction to Chapter 1, and I'm also going to include Chapter 1, Section 1 as well. So hopefully by watching this video, you'll be able to do all the problems in the introduction and in Chapter 1, Section 1. So first of all, in regards to statistics, what statistics is, it's basically is the study of data, right? And so data is basically information about individuals. So the information can be either categorical or quantitative. So anyway, and let me say this from the very beginning, the best way to understand statistics is in a context, and is by seeing different contexts, seeing different problems. And so memorizing definitions isn't so much the way to go, even though it's not a horrible idea. But the best way to really understand this stuff is to see different word problems and to see different contexts. And so that's what we are going to try to do. And to me, that's what your book does, and it's what we're going to try to do in this class, is try to explain different things in a context. So first of all, the introduction is mainly these terms here, mainly categorical and quantitative variables. But let me see if I can explain these things to you. And look, anytime you have a question about any of the material, please send me your question. Some of these concepts can be more difficult than others, so it can be a bit of a struggle to learn this stuff, but you can do it. Just hang in there and ask questions about it. And you may not understand everything initially. Okay, matter of fact, you won't understand everything initially. It'll take some work and it'll take some studying, but you can do it. And this is, I think, going to be really useful stuff for you in the future. So the first definition that you need to be aware of is when we talk about the individuals are just the individual units, the people, animals, or things that we're studying are described by a set of data. So it could be like all the people in the United States, or it could be, doesn't have to be people, it could be all the trees in a forest, or all the cars made by a company, or all the bags of potato chips made by the potatoes. It's just a whole group you want to know something about. And so that's what the population is, the entire group of individuals you want to know something about. You want to know the average 40-yard dash time for a group of athletes in a city. So the population is all of those athletes. Or you want to know the average height of trees in a forest. So the population is all of the trees in the forest. So the term population is just a whole group you want to know something about. And the main goal for this section, I think, aside from just this basic terminology, is being able to tell the difference between a categorical variable and a quantitative variable. That comes all the time on the AP Stats exam. And it can maybe be a little bit tricky, but categorical variable is just something about the individuals that categorizes them. And quantitative is some basically numerical value about them. For instance, in regards to people, a categorical variable, so get a categorical in regards to people will be things that categorize them. You know, what state they were born in, the state of birth. State of birth. And whenever you list variables, you need to always say how they vary in some way. List a couple. So in other words, Alabama, Mississippi, and ... And you know why you need to do that, we'll talk more about later, but you have to properly identify how it's varying whenever you state a categorical variable. So the state of their birth, another categorical variable in regards to people is their race. So you could say, you know, white, Asian, comma, ... like that. Just say how it varies. So there, you know, it could be eye color. Eye color would be categorical. So that would be, you know, it could be blue, it could be brown, ... like that. And so now quantitative is something that's a numerical value in general. So in regards to, you know, quantitative in regards to people, it could be like their height in feet, And so in quantitative variables, everybody has a different number. It's not necessarily categorizing them, but the way that you identify them, make sure to put the units, or it could be their weight in pounds, okay? Always put the units, okay? Now, some things may not have a unit, like a test score. It could be the test score. But quantitative in general is when everybody in your study has a different number, so to speak. Now, some of them might have the exact same number, but categorical in general, most of the time is not a number. It is just something that's categorizing them. What state they were born in, what their hair color is, all right, the type of car they drive, whether they live in a house or an apartment, something like that. Quantitative is everybody's got a number like that. There are occasional times it can be confusing. Like for instance, like most of the time quantitative is number, but like if you did what grade people are in, ninth grade, 10th grade, like that, 11th grade, those are numbers, but it is categorizing them. All right, and notice what it says here, quantitative, that takes numerical values for which it makes sense to find an average. And so it doesn't really make sense to say, well, this person's in ninth grade, this person's in 10th grade, so it's an average of 9.5 grades. You know, it doesn't make sense to average these numbers, okay? Whereas if you're doing height and weight, and you say one person weighs 140 pounds, another person weighs 160 pounds, you add them up and divide by 2, so their average is 150 pounds. That has meaning to it. So anyway, but like I said, the key way to understanding concepts is just looking at different contexts. And all the distribution is, it's just every value a variable takes and how often it can take it. So the distribution is just, you know, it is in essence just a list of numbers is what it is. And so if you listed, you know, everybody's height and say, you know, this person was, you know, 6 feet 2 inches tall, and this person was 5 feet 5 inches tall, and so forth. The distribution is just a list of numbers. Okay, so when it says, you know, to look at this distribution, it means look at the list of numbers. Now, if it's categoricals, the numbers are going to be counts and categories. You'd say like there's 15 people from this group born in Alabama or whatever. So that is basically the terminology that is in the introduction. And it'll ask you some questions about that terminology. So that is in essence what you need to know there. And here's some terminology. Now, section 1.1 is basically dealing with categorical data. All right, and so basic things in regards to categorical data and a two-way table. And so to understand what these terms are, the best way to understand these terms are is we're going to look at a couple of examples. So a categorical variable, we just described it as a variable that categorizes your individual, where your numbers are counts and categories. And it's not like every individual is going to have a different number, okay? So anyway, so the distribution of categorical variables, the frequency or percent of each category. And like I said, I'm going to do an example that explains all of this. All right. So you have to be able to draw a bar graph, a side-by-side bar graph, and a segmented bar graph. I'm going to show you an example of that. You have to be able to work with a two-way table, and I'll show you what that is. All right. You have to be able to create a marginal distribution, which is just numbers in the margin. I'll show you an example of that. And a conditional distribution, which means find the percent in each category. And we'll talk about that. And what is an association? When you're asked, are two variables associated? It just means when knowing the value of one variable helps you predict the value of another variable. So for instance, so association B would be between two variables would be something like, let's say variable A is whether or not it rains today, and variable B is whether or not I go golfing. Now, so and those things are definitely associated, because if it rains, it means the probability of me going golfing just went way down. Okay, so in other words, it affects it. Anyway, but we will talk. So we're going to talk about all this in our little example, and here is our first example of the year. And so we'll use this to try to explain those concepts. So it says, an administrator at a school wishes to see if there's a relationship between the gender of the students and their opinion of the quality of the school lunch program. He takes a random sample and gets the results below. So what this says, in this sample, he had males and females, and then he recorded their opinion about the school lunch program. So good, fair, and poor. So you had 18 of the males said that it was good, and 16 said it was fair, and 5 said it was poor, and so forth. Okay, so the first thing that it asks us to do, this is a two-way table. This is distinctly categorical data. These numbers are counts and categories. It's not like every individual has a number here. It's not like you're doing people's heights or their weights or their time that they slept last night or their shoe size or something like that. I mean, it is categorizing. That number is not the number of one person. That is a count in a category. So these are distinctly two categorical variables, the gender and their opinion. Marginal distribution just means this. It means write the numbers that are in the margins. It means total them up. And so we'll add them up. And so you would say 18 plus 23, that's 41. There was a total of 41 people in the study that said that had a good opinion of the school lunch. And then so you have 16 plus 38 is 54. So 54 said poor, and I mean said fair, and then 5 plus 46 is 51 that said poor. And if you add all those up, those add up to 146. Okay, that is the total number that are in our sample. Then if you add 18 plus 16, and so that, by the way, is in essence, the column distributions. The column is by adding those up. Now, in regards to the rows, we'll add up to 18 plus 16 plus 5, and so that there's a total of 39 males, and the total number of females, 23 plus 38 plus 46, that's 107. That is the marginal distribution. It's those numbers that I wrote there. And so that's how you do that. All right, the conditional distributions for males and females. Conditional means find the percents. Find the percents in each category. Find the percents in each category. So what we would do, and it says do it for males and females. So we'll do for the males first. And so what percent of the males said good? And so you would say 18 divided by 39. So 18 divided by 39, when you do that, that's 0.462, like that. And then what percent said fair? Well, that would be 16 divided by 39, and so that's equal to 0.410. And what percent said poor? And that would be 5 divided by 39, and so that's 0.128. Hopefully you can read that, 0.128. All right, and so then for the females, you would say 23 divided by 107. 23 divided by 107, and that would be, in essence, the proportion that, so 0.215, or about 21.5% of the females said that they thought the food was good. And then 38 divided by 107 is 0.355, and then 46 divided by 107 is 0.430. Those numbers that I wrote there, those proportions, these decimal numbers, that is what is known as the conditional distributions for males and females. So conditional just means to divide by the number. And this would be the row, by doing it by row here, because it asks for males and females. So you divide each value by what's at the end of the row. Now, it could have asked you to do it by column. In other words, it could have said find the conditional distribution for opinion. So for good, fair, and poor. In other words, what percent of the people that said good are male? And you would say 18 divided by 41 and get that. And 23 divided by 41 and get that. And then for fair, you divide like that. So that would be dividing by column. That would be the column conditional distribution. But it asks us to do it for row. And so there we go. All right. So whenever you're asked to graph categorical data, basically you're going to make a bar graph or a pie chart, even though pie chart is sort of a rare thing. I'm going to show you how to do that, but the main thing is be able to make a bar graph. In this case, we're going to make a side-by-side bar graph since we have two variables. And so this is what we will do. And so to make our side-by-side bar graph is we will draw it like this, make sure to label and scale your axes. And so I'm going to make it like this. I'm going to say the open box represents male. And then the filled in one represents female. Okay, and then my vertical axis here, and so this would be, proportions, or you could be percents, proportions. And so I noticed so basically I'm just going to graph these 6 numbers, those, those, and those. The biggest one goes up to about 46%. So I'm going to go 1, 0.2, 0.3, 0.4, 0.5, 1, 0.2, 0.3, 0.4, 0.5. And then, so we will say, well, what percent said good? And so in regards said good, well, with the males, it was 0.462. So I go up to 0.462. And so that's about there. In regards to the females, it was 0.215, and so that's about it doesn't have to be the neatest graph in the world. We just want to, in general, see what's happening with the data. So that would be that. Now, in regards to those that said fair, the males go up to 41%, so 41%, so that's like that. And then the females is 36% roughly, 35.5%, so that's about like that. And so like that, and then, so that's like that. And so then we say poor. So in regards to the poor, so that would go up to 12.8%. So that's about like that for the males, and the females, it goes up to 43%. And so like that. And that is how you make a side-by-side bar graph, which is sort of, the main, that's the main graph you got to be able to draw. That's how you do that. All right, and so then and it also asks to do a segmented bar graph. So that's a side-by-side bar graph. That's how you do that. To make a segmented bar graph, what you would do is this. And so, so you would draw a little thing. I almost made that a little too big, but I'll do it like this. And so for the males, what percent said good? And so, so for the males, 46% said good. So I'll go like this. So 46.2% do like that. And for a segmented bar graph, you're going to stack them on top of each other. And then it said fair. So fair was, and so fair, and I wrote the data right here. So the fair for the males is 41%. And so I would go, and so 46 plus 41 would be 87. So I go up to 87. And so that's about like that. And so that's going to get marked like that according to my key. And then lastly, that said poor was 12.8%. So that would take us up to 100% like that. And so then we'll fill that in strongly like that. And so then for the females, we have 21.5%, 35.5%, and like 43%. So 21.5% said good. So that would go up to about there. And then we would have about 36%. So that would add up to, about 57%. So that's going to go up to about there. And so that said fair. And then poor 43%, which is the rest of the way. And so that is what we call a segmented bar graph. You just kind of stack them on top of each other like that. So that is a segmented bar graph like that. And so if you're asked to describe the relationship, so going back to this, if you're asked to describe the relationship between the two variables, you just describe what you see. You would say, well, the males are much more likely to say good or fair, and the females are more likely to say poor. And that's what that graph is communicating to me. There appears to be a difference. And of course, the segmented bar graph is showing us the same thing. The females are much more likely to say poor. The males are much more likely to say good. And so that's what you would say. All right. When it asks, is there a relationship or is there an association? An association between the two variables means if there's a difference in the groups. And so what you would say here, is there an association? You would say yes, because the males and females differ significantly. And the concept of statistical significance, we're going to be talking about a lot this year. We're going to be a little bit more definite about this. Differ significantly in their opinions. That's what an association means. Association means if they're different, okay? If the males and females are different. Whereas if the bars were roughly the same height for good, fair, and poor, we would say there's not an association. There's not a relationship. And so they're distinctly not independent. So that's what an association means. An association means if the value of one variable is associated with a change in the value of the other. So if I told you someone was male, you'd immediately say, well, there's a good chance they're going to say good. But if I told you they're female, there's a good chance they're going to say poor. So that means there's a relationship between the two variables. And so that's really the main part of section 1. Now I did want to show you, I want to say a couple things to you. I want to show you how to make a pie chart or a pie graph, okay? And so even though that has never been on the AP Stats exam to create one, but what has happened is they'll give you a pie chart and ask you to comment on it. So And it shouldn't be that difficult a thing. And there's also a problem in your assignment. So let's say in this particular study, we took a simple random sample. This is going to be a really important thing later in the year. SRS stands for simple random sample of 162, let's say, students at this school. 162 students at a school. So that's what N is. N is our sample size. And 42 of them said their most used social media app was Twitter. 18 of them said their most used social app was Facebook. 71 said Snapchat. 23 said Instagram, and 8 said other. All right. And so what we're going to do in order to make a pie chart is we need, in essence, the percents of them that like Twitter. Okay, the percents of them. And so say 42 divided by 162, which is 0.259. So that is 25.9%. All right. And so Facebook is 18 out of 162. And so that's 11.1%. And so this for Snapchat, that would be 43.8%. And then for Instagram, so that would be 14.2%, and then 4.94% for other. So this is how you can make a pie chart, and I'm kind of, don't have a lot of room here, but you make your circle, okay? It doesn't have to be exact. Like I said, the main thing is being able to read this. And so, let me zoom out a little bit here so we can see the numbers. So, okay. And so what I like to do is I just divide the pie, the circle, up into fourths. I just draw 2 lines to divide it up in fourths. And so every one of those is 25%. And so then I take the biggest number. So the biggest number is Snapchat. So it's 43.8%. So if you take this, and I'm just going to go, so there's 50% right there. So 43 point, if I cut this off and just estimate it as best I can, and if I go like that, okay, so this section over here is 43.8. So that would be Snapchat. That would be Snapchat, like that. And so then, so that takes care of that one. The next biggest one is 25.9%. That's Twitter. All right, so 25% is this 1/4 of it, which is this wedge here, but a little bit, just a little bit more than that. So if I cut it like that, I'll erase my little dotted line there. So like that, and so that would represent Twitter. So I'll label that as Twitter. Okay, then it can get a little bit tricky. So the next biggest one is Instagram, which is 14.2%. Now this 25% here, okay, this quarter of it, half of that's going to be 12.5. And so this is 14.2. So it's a little more than that. So I'll just mark that a little bit more than that, like that. Okay. And so this part here would be Instagram. So we got that. Then Facebook and other are the ones we have left. And Facebook is a little bit more than twice other. So of this thing, I need it to be a little bit more than twice Facebook. So I'll just kind of estimate that to be that. That appears to be about twice as big as that. And so that would be Facebook. And so this would be other. And that's how you make a pie chart. Okay. And so, but like I said, the main thing is being able to be able to look at that and to be able to estimate. Twitter is about 1/4 of the thing, and Snapchat's a little bit less than half, and that sort of thing. So, and so that is that. Now, and then a couple other things. All right, let's talk about deceptive graphs. There's a number of different ways you can lie with statistics. You can lie with graphs. There's a couple of problems in your assignment in regards to that. One of the things is scaling. Like, let's say if I told you, so if we had this graph, and so here is time, and let's say this was test score. These are test scores. So these are what the test scores have done. And if I drew a graph that looks like that, I think you would clearly say, well, the test scores have gone up a lot through time, but we don't know the scaling. Always look at your scaling. That is one of the main things. Like, let's say if this here represent 94.1, and then this up here represents 94.11, okay? So it looks like they've gone up a lot, but because of the scaling, if we did this, from 0 to 100, which in this case would probably be the best thing to do that. All right, now the graph is just going to go straight across. And we would realize, hey, these test scores really haven't gone up significantly. They basically have not changed. So always pay attention to your scaling. That's one way that people can lie. with statistics. And another way is this. So let's say in regards to the use of a bar graph, so let's say if it did something like this, and so you have these, let's say these two companies that are oil companies, and so this represents thousands of gallons they make in a day, I don't know, and so this is 1, 2, 3, and 4,000 gallons, and let's say in 1990, it was 2,000 like that, and so then in the year 2000 it doubled and it goes up to that, and so that's a good bar graph. It communicates, hey, 2000 was roughly twice of 1990. What you don't want to do is increase the width of it as well. You want it to be, in essence, just one. You want bar graphs to be one-dimensional. In this case, height is all we care about, because if you double the width, and you go like that, now visually it looks like it more than doubled because the area just went up 4 times. Okay. All right, so in other words, whenever you make a bar graph, the width needs to be the same. So this graph is wrong proportionally. What we would say about this, because you increase the width of the graph, it tells a different picture proportionally. Now, if you did it with 3-dimensional figures, that is also a big time problem. So let's say if you had something like this, and I tried to draw 3-dimensional figures where this doubled, okay? It was 2,000 gallons of oil and it increased to 4,000, but by drawing a 3-dimensional figure, it looks like it went up a lot more. So what we would say here, when you're asked what's wrong with this graph, you would say because it is using a 3-dimensional figure, it makes it appear that it has gone up a lot more, and the graph is not proportional to what is happening with the data. So that is what we would say there. The last thing, and hopefully this hasn't been too boring for you. The last thing is I want to make you aware that, okay, let's say if you have a bunch of quantitative data. Okay, quantitative just means every individual kind of has a different number. So let's say at the heights of trees in this forest. And so this tree is 10.7 feet tall, this tree is 21.7 feet tall, and so forth. Everyone has a different number. This is clearly quantitative because it's a number. But any quantitative variable you can express in a categorical way by making intervals. And so in other words, sometimes you'll see this, like if we made intervals, and if we counted them in the intervals. So let's say if we counted every tree that was between 10 and 20 feet tall, and then between 20 and 30, and then between 30 and 40, and then between 40 and 50 or whatever. And then we did their frequencies or their counts. And so we counted up, there was like 10 trees that are that high, and there was 12 trees there, and 14 trees there, and 37 trees there. So now the numbers in this are categorical because it's categorizing them. This isn't a number that goes with one tree, it is a count in a category. So it's like now it's like this height is a categorical variable. Okay, whereas here it's quantitative. And so for instance, if you made a two-way table, let's say if you had a bunch of trees and you had oak trees, pine trees, and elm trees, and you counted the ones that are between 10 and 20 feet tall, all right? And so this is categorical data because the numbers are counts in categories. Even though ordinarily, most of the time you think of height as quantitative, it's quantitative if you list it like this, if you list like the height of every tree. Okay, that's it. That's section 1 and the introduction. And I'd like to thank you for watching my video. Please send me any questions or comments you have about any of this stuff. Please read your book and think about this stuff and do your problems. And I hope you just have a great day.